Hello and welcome to the 8th lecture on our series on logic. In today's lecture, we'll be discussing about conditional statements. We begin by considering two simple statements, P and Q. So they are going to be combined to form a compound statement using the help of some logical connectives. In the previous lecture, we have already discussed about logical connectives such as the conjunction, which is and the disjunction, which is an or. If we have a statement of the sort, if P, then Q, what we have done is we have formed P and Q by joining them with the help of a connective, and this connective is referred to as if then. Then in that case, what we obtain is a conditional statement. So they are also referred to as an implication, and usually they are written in this particular symbolic form, P arrow Q, or P implies Q. So here, when we have such a statement, P is referred to as the antecedent, or sometimes it's referred to as the hypothesis. Then we have Q. So Q will be referred to as the consequent, and also referred to as conclusion. So this particular implication or conditional statement, P arrow key, so there are several ways to express this particular expression. So we have already mentioned that P implies Q. This is one way. Then another way would be if P, then Q. Then third way would be Q if P. Fourth way would be P only if Q. 5. P is sufficient for Q. So sixth one will be Q is necessary for P. Like I said, these are like the 6 examples, the 6 ways. So these are the 6 different ways of telling the same thing. So all of them means we are talking about a conditional statement. So let's consider a few examples. So here we have like somewhere around 8 statements. So let's talk about each of them one by one. The first one is like if it rains, then the atmospheric humidity increases. So this is a if, then it's a conditional statement. So here, if it rains, so this is the antecedent or the hypothesis, and then the atmospheric humidity increases. So this will become the consequent. So representing antecedent and consequent with the letters A and C respectively. Number 2, if x equals 5, then square of 5 gives us 25. So this is an if-then statement, conditional statement. So antecedent will be x equals to 5. Then 5 squared equals 25 will be the conclusion. Number C, if ABCD is a parallelogram, then AB equals to CD. We know this is a true statement. Here, if ABCD is a parallelogram, so this will be the antecedent. Then AB equals CD, so this will become the consequent. Number 4, we will start with a hypothesis that if ABC is a right angle triangle at B, so that means we have a right angle triangle A, B, and C. Here the right angle is at B. Then the hypotenuse square, SE squared, will be equals to opposite squared, AB squared, plus the base squared. So this is the conclusion. Number 5, if x is a rational number, then x over 2 must be a rational number. So we start with the hypothesis that x is a rational number. We can check it out. So let's say x be 1 over 2. So this is a rational number. Then we are saying that if we divide that rational number with 2, then what we'll have? We have 1 over 2 divided by 2. So that gives us a new rational number, 1 over 4. So this is the consequent, which is, this is the consequent, which is true. Number 6, if 4 plus 4 equals 8, then Diet Cola is a soft drink. Now, 4 plus 4 equals to 8. So this is the hypothesis, and we are saying that the conclusion is that the Diet Cola is soft drink. Now let's look at 7 and 8 as well. Like if Joe works hard, then it will rain today. Number 8, if Paris is in France, then 2 times 2 equals 4. Now clearly there's a distinction between statement 1 through 5 and 6 through 8. Now let us consider example 1, 2, 3, 4 and 5. The hypothesis or the antecedent and the conclusion or the consequent, they have got related subject matter. Whereas if we consider number 6, 7 and 8, here the antecedent, which is 4 plus 4 equals to 8, Joe works hard, Paris is in France, this is not following the consequent. So they don't have the same subject matter. However, such type of statements are also acceptable in logic. Primarily, we'll be dealing with mostly when both the antecedent and the consequent have the same subject matter. So let's consider first example. The square of an even integer is even. What we need to do is we need to rewrite the following statement in the form of a conditional statement. So the first one will be, let's say, if an integer is even, then its square is an even integer. So here we have converted the given statement into a conditional statement. Next one, the square of a prime number is not prime. If a number is prime, then its square is not a prime. Number 3, if two integers are such that one is even and the other is odd, then their product is an even integer. And fourth one is a little funny. When you sing, my ears hurt, which will be, if you sing, then my ears hurt. Let's move on to the next problem. So here we have a couple of statements. We'll convert it to a conditional statement, as well as we will write it in the symbolic form. So for that, let's begin by breaking down the given statement into two statements, so since each of them a compound statement. So we'll consider the first statement P, a necessary condition that a polynomial f of x is divisible by x minus a is that f of a is equals to 0. So here we'll state that let P be the statement which states that a polynomial f of x is divisible by x minus a. And we'll consider statement Q as f of a is equals to 0. Then this particular statement will become P implies Q. That means if a polynomial f of x is divisible by x minus a, then f of a will be equals to 0. Next, number 2. This will be slightly trickier. Here we have used the word sufficient. So here it states that a sufficient condition that a quadrilateral ABCD be a rectangle is that it be a square. So in that case, so this is the antecedent and quadrilateral ABCD is a rectangle, so that becomes the consequent. So if we have the statement P given by ABCD is a square and the statement Q is ABCD is a parallelogram, then we can say if ABCD is a square, then ABCD is also a parallelogram. In symbolic form, it will be P implies Q. Third one, a necessary condition that a quadrilateral ABCD be a rectangle is that it is a parallelogram. So ABCD is a rectangle, so that is the antecedent, and ABCD is a parallelogram is the consequent. So let's rewrite the two statements as P and Q. So P will be ABCD is a rectangle, and statement Q, ABCD is a parallelogram. Actually, the statement P will be quadrilateral ABCD is a rectangle, quadrilateral ABCD is a parallelogram. So our statement will be if quadrilateral, this is the statement P, ABCD is a rectangle, then ABCD, then the quadrilateral Q, ABCD is also a parallelogram. And in symbolic form, this will be if P, then Q. Fourth one, let's come to the fourth example. A sufficient condition for a positive integer n to be divisible by n is that the sum of the digits of n be divisible by 9. So our statement P will be the sum of the digits. Since this is a sufficient condition, then the sum of the digits, this will become the antecedent, and the consequent Q will be the positive integer n is divisible by 9. So our conditional statement will be P implies Q. That means if the sum of the digits of n is divisible by 9, then the positive integer n is divisible by 9. Example number 3. So let's say we have two simple statements, P and Q. P states that I am rich. Q is the statement I am happy. Now what we need to do for each of the three statements, 1, 2, and 3, we need to rewrite it in the symbolic form. So let's begin with the first one. If I am rich, then I am unhappy. Now, in order to write it in the symbolic form, we need the negation of each P and Q. So let's write them. So the negation of P will be I am rich. The negation will be I am poor. And negation of Q will be I am happy. That means I am unhappy. Now, let's come to the statement. If I am rich. So this is the antecedent. I am rich. This implies then I am unhappy. So I am unhappy will be not Q. Coming to the second one, which is a little bit tricky. So it is using the word necessary. So it is necessary to be poor in order to be happy. So generally, this becomes the antecedent and this becomes the consequent. So in our case, we will rewrite it as to be happy means we have Q implies, so this is the antecedent, the Q. Q will be the statement I am happy. Then this implies poor. Poor means not P. Or you can also rephrase this statement as if I am happy, then I am poor. Number 3. To be poor is to be unhappy. So to be poor means not P, implies to be unhappy, that is not Q, which will be if I am poor, then I am unhappy. So here we have three simple statements, P, Q, and R. P is today is Sunday, Q is it is raining, and R it is cold. So using these three statements, we have to form the given compound statement. So number 1 is P implies Q. So this will become if today is Sunday, then it is raining. Number 2, we have not P implies Q or R. So not P will be today is not Sunday. So we'll write if today is not Sunday, then it is, so we'll start with Q. Q will be it is raining, and since this is a disjunction, it will be or it is cold. Then number 3, so we have not Q implies R and P. So not Q will be it is not raining. So we'll say if it is not raining, so this is the negation of Q, then it is, so we start with a statement R is it is cold, so it is cold. We have this conjunction, so this will be and P is Sunday, so and it is, and today is Sunday. So this is how we can express different conditional statements.